Hey guys, here we are for Chapter 19, Section 4, Slowing Climate Change. Well, let's go ahead and tuck in. We've got a lot of ideas here, so let's get into it. Now, right off the bat, we can reduce carbon greenhouse gas emissions and the threat of climate change that comes with that, but we can do it while saving money and improving human health. It's not we do it and it's bad. We can actually do it by saving money, helping out human health, et cetera, et cetera. We need to reduce our energy waste just right off the bat. Any kind of thing we can do for prevention and helping efficiency, reducing waste is paramount, and we need to rely on cleaner, renewable energy sources. The brunt of it is we need to wean ourselves off of the fossil fuels, but let's go in and take a look. Now, when we talk about dealing with climate change, it's difficult, period. There are all kinds of factors involved. Our lifestyle, a cultural lifestyle, we are already embedded in a lot of infrastructure, and it means changing a lot of that. This is why it's difficult. You're looking at it from a political standpoint, an economic standpoint, and just a practicality of how do we go about it. There's a lot there. It's a global problem as well. It can't be solved just by us. America could go completely green, 100% renewable, and it wouldn't solve the problem. It's global. We've got to get it happening all around the world. So it's going to require literally unprecedented and prolonged international cooperation. The closest thing would be like the banning of the chlorofluorocarbons, but we were fortunate there that it was only a handful of companies that actually made it. So even though it was a international, everybody coming together, honestly, it came down to a handful of companies that had to get on board. With our greenhouse gases, it's not that easy. It's going to be a long-term political issue. Most of the people that are really going to suffer the most from this, they're not even born yet. So it's a long-term political issue, and it's very difficult to get senators, congressmen, anybody that's in power to really want to act on a long-term plan, because they're only thinking 4 years down the road. And the things that we do now, they're not really going to see the benefit of. This is long-term stuff, so politically it tends to be difficult. The harmful and beneficial impacts of climate change are not going to be spread evenly around the world. So once again, some areas where it's colder will actually get a little longer growing seasons. It can be a benefit. Other areas are going to go to more desert, but it's not going to impact everybody the same, which also makes it difficult, once again, from all of these standpoints. The proposed solutions are controversial. Nobody completely agrees with any one of them, because no matter how we go about it, there's going to be some economic disruption. Even if we're just switching from coal plants to natural gas, which we've by and large been doing, there's disruption in it. And we want to start talking about taking our fossil fuels offline. Well, there's large economies based behind those, and there's pushback from it. There's just going to be some disruption. The projected effects are uncertain. It's difficult to plan for avoiding or managing risk when we don't know exactly what it's going to be. But it's difficult to do that because the projected effects, it's not exact. It's a huge climate. There's a lot of factors involved in it. We have an urgent need for more research to help reduce this uncertainty. We have a lot of climate scientists out there. They're doing it. They're looking at the research and they're trying to put in the models. But once again, it's uncertain. There are some things we feel very confident about, and other things that could go this way, it could go that way. So what are our options? What do we do? It is difficult, it's long-term, it's involving politics, economics. A lot of the people that are going to suffer the most aren't even born yet. It's for a later generation, but we've got to act. So what do? Well, number one, really mitigation, all right? We've got to try and mitigate the problem. We've got to slow climate change. If we can slow it down, we can avoid some of the most harmful effects. Remember, The life cycle of nitrous oxide can be a few hundred years. Carbon dioxide, which is the one we put up the most, still is about 100 years, somewhere between 50 and 200. So if we stop right now, it's still in the air, but we can do things to slow it and it can come down, just like the ozone hole. It's healing. We stopped it 20 years ago in a sense, and it's healing, but it takes time. And this is what the climate change will be like a while. Adaptation, all right? We've got to recognize that climate change is inevitable because we've waited too long to act. We can't say, ooh, bummer, let's stop. It's already too late. We're seeing the effects of it already, but we have to now adapt to some of these harmful effects. Some people have to move from areas where they are. Climate is already changing. Spring's coming sooner. Summer's staying a little longer. Wind patterns, the ocean currents are slowing down. Some of this is already there, and we just have to adapt to those harmful effects. Our most urgent priority is to avoid those climate change tipping points. There's some things we've been able to identify. We've got to stay below this. We've got to try and keep this from occurring. So our most urgent priority is that, avoiding those very specific tipping points. Now, most of the world's economies currently right now depend on using fossil fuel reserves. The known amount of oil, coal, natural gas that's in the ground. Shift is difficult, but we've done it before. We shifted from wood to coal, we shifted from coal to oil, and we've shifted from oil to natural gas. Each one of these shifts took about 50 years and a painful process along the way, but we've done them. We're in the middle of another shift. Now, we have some good starting points, all right? We can decrease our black carbon, basically like soot, coal being the worst, and our methane emissions. The technology exists to do that pretty quickly. Scrubbers, electrostatic precipitators, once again, even catalytic converters, a lot of stuff to get rid of the black carbon and our methane emissions. Technology's there, we can do that. And we need to start making the switch to more hybrid and electric cars. We've got to get better gas mileage, and once again, switching to hybrid and electric cars will go a long way, and a lot of us already are. My car is an electric car. Many people are already opting to those, and this is a really good start. Now, some of our solutions, the graphic we have back here, just running through it. We have prevention and we have cleanup. Prevention is always best. So what do? Cut the fossil fuel use, especially coal. We've got to start pulling those plants offline. We can shift the coal to natural gas. Fairly easy, it's much cleaner, and it's a good intermediate step. We need to repair all of our leaky gas pipelines and facilities. We don't want any of the methane just leaking out. That's something we've got to address. Shift to renewable energies. We have renewable energies out there. We normally talk about solar and wind, but of course water, hydroelectric, there's a big mix, but we need to shift to those as much as possible. We've got to reduce our deforestation. In America, we've done a pretty good job of replanting and getting our trees back. Costa Rica has been fantastic, but once again, around the globe, something we need to do. Use more sustainable agriculture and forestry. We've got to keep our forests sustained and put a price on greenhouse gas emissions. Anybody who's given off greenhouse gas, they need to be taxed for it. That money can go into subsidies for, renewable energies, all sorts of things that tax money can be used for, but we got to start taxing it. Cleanup, all right? We need to do the prevention, because without prevention, we're always cleaning up. But some of the things that we can do, sequester the CO2 by planting trees, planting more trees, perennials, area where the land's already degraded, let's make sure that we get plants growing on it so it pulls CO2 out of the air. We can sequester our carbon in the soil using biochar. Some of our say chicken poop or something. Well, it's going to have carbon dioxide that leaks out. You heat it till it becomes charred. You don't burn it completely. We can bury that in the ground, sequester it under the ground. Sequester CO2 in deep ocean areas. So we can capture carbon dioxide and then we can sequester it underground. We'll look at some things of that in a little bit. And then just remove the CO2 from smokestacks and vehicle emissions. Kind of like how our catalytic converters are taking out some of the poisons. Well, we need to start taking out some of our CO2. I love this graphic right here, or this comment, you know, it's got energy independence, preserve the rainforest, green jobs, livable cities, all these great, wonderful things. There's this guy, yeah, what if it's a big hoax, right? And we created a better world for nothing. Yeah, a better world's a better world, dude. That's what we're after, right? Now, how do we remove CO2 from the atmosphere? You know we can plant trees, but you know, beyond this, what do we do? Well, the solution strategies. The first one is plant trees, right? Global tree planting, forest restoration programs. Let's make sure we get into areas where there has been deforestation and help out, and let's get the forest replanted. We need to restore the wetlands that were drained for farming. Farming, there's crops on it some of the year, not some of the year. That means they're not pulling CO2 out. We need to restore the wetlands. Wetlands have greenery year round and they do a lot to clean it. Once again, we've talked about wetlands, they need to be restored. Fast growing perennials on this degraded land, we need to put in grasses, perennial plants, ones that just come back up. We don't have to keep planting them so that they're pulling. Once again, all of our degraded land, let's make sure that we can get plants growing on it. Produce and bury the biochar. Once again, you heat up some of this organic matter till it turns into charcoal. You don't have to burn it, you just heat it up and it chars over. Then we can bury that in the ground and it stays sequestered under the ground. And we need to capture and store our carbon from our plants. The graphic back here is kind of showing that. Now we've got like a big offshore, like where we used to have oil, or we can pump the carbon back down into where these oil wells were. Now we got to make sure we put it in there, it seals up, but where those billions of barrels of oil and natural gas, we still have the natural cavern down there. So we could pump our CO2 back into it and seal it. Of course, the downside is if it leaks out, then it's no good. We can also put the carbon back down into some of our depleted coal reserves, and then the carbon down with certain type of rock formation will turn into calcite, and then it remains there permanently. Kind of like limestone, right? Limestone is calcium carbonate, carbon in it. Calcite, largely carbon, but it turns into solid form, remains underground. That graphic is showing some of the ideas, pulling it out of the plants, pumping it right underground, or hauling this captured CO2 out to sea and putting it back down under where we have depleted oil fields. We already have the infrastructure in place for pulling it out. We just got to reverse and put carbon back in it. These are ideas. And that kind of takes us to this term of geoengineering, all right, engineering the planet. Now, once again, we're talking about what do we do in climate change. Some are easy, plant more trees. Let's make sure we get the greenery out there. Cut down the fossil fuels. But some of it is, can we do something about what's here? Or how we're not going to cut fossil fuels everywhere right away. What's an intermediate step? That's the sticking it underground. Well, geoengineering is kind of going a step farther. This is manipulating the natural conditions of the world, what's going on, to counter the human enhanced greenhouse effect. So it's happened, so now we say, well, let's transform the planet to counter what we did to the planet. Once again, here's the idea, the concepts. We could inject sulfate particles into the stratosphere. The sulfate particles, they reflect more sunlight, so it reflects more out, so not as much albedo comes down, reflects up, not as much sunlight making it to the ground, reducing the overall temperature. Similar concept, but spraying seawater, very large ships, if you will, think like oil rigs, and they could spray seawater directly up into the sky to make the clouds more reflective. Once again, there's more particle, it's denser, there's more particulate matter in the seawater, it would reflect more sunlight. Sulfate powder in the sky, salt water in the sky, making whiter clouds, reflecting more. Also, there's an idea that we could pump nutrient-rich water from the deep ocean. Remember, most of the ocean is not very NPP, right? There's not much net primary productivity in the open ocean because there's not much nutrients. We pump the deep nutrients from the bottom up to the top, and this would feed algal blooms. So that way out in our ocean, we could have more algal blooms, greater numbers of phytoplankton, pulling CO2 out of the air. These are some of the concepts of geoengineering. So if you look at the graphic here, this is what we're talking about. Some of them are trying to put these big mirrors up there in the sky that would reflect some of the light, and then also, the sulfates and pumping the seawater. But that's what the graphic is just trying to show, some of these ideas. Well, problems with it. Problems are they may not be fairly obvious, but they should have raised some red flags even when I'm talking about them. We have unknown side effects, right? Pumping sulfates up into the air, well, they gonna come, what goes up must come down. As the sulfates come down, they can cause problems as well. Salts, they have issues. Huge investments of energy and materials. We would have to continually pump, because once again, we're just saying, hey, can we make the planet adapt to what we're doing? Maybe as an intermediate, if we stop everything we're doing, we could do this to help keep it until it's able to heal. But this is something we would have to continue to do. And if we don't stop, if we don't do the prevention, then we'd have to do this geoengineering forever, if you will. So it can be very expensive and using lots of materials. We're talking about putting sulfates into the sky. We got to create it. We got to get it up there. Lots of difficulties. It could also justify continued use of fossil fuels. Oh, hey, we're doing this, so it's okay to use the carbon fuel. Ooh, we're paying for that to happen so we can continue to use our fossil fuels. So once again, trying to solve it by geoengineering may just encourage us to continue doing what we're doing, which is not really the best way to go about it. We have political and ethical aspects. Once again, if we're causing algal blooms happening, normally we're trying to stop algal blooms, right? That's what a lot of our runoff and fertilizer problem is. We're disrupting food chains. Once again, this comes down to the unknown side effects. And then there's a whole bunch of political aspects, because one country says, we don't think you should do it, and another country is going ahead and doing it. So the geoengineering, once again, we're throwing the ideas out there. What do we do? What could we do? Those are some ideas that come with a lot of issues. And, if we decide to go that route, it's going to be when things are probably getting pretty bad. And when it comes to regulating them, one of the things is just that. We need to regulate our greenhouse gases as pollutants. Now, once again, carbon dioxide, methane, overall, they're not really pollutants. They're like when you breathe them in, they're not causing problems. So it's a matter of trying to regulate them and put them on the list of pollutants, if you will. And any kind of pollutant, as you will, is really based on a concentration in the atmosphere. Anything that's a pollutant is in the atmosphere to a degree, but when it reaches a certain point, then we say, okay, now it's a pollutant, now it's bad. Very small amounts, it's irrelevant. Now in 2009, the EPA classified several greenhouse gases as a danger to public health. Fossil fuel companies have successfully opposed this regulation. Carbon dioxide is one of them. For a long time, we've tried to put carbon dioxide as a pollutant. Fossil fuel companies have prevented it from actually happening, and it's sort of in the air. It does lead to greenhouse effect. It is a greenhouse gas, but is it a pollutant or not? Well, it's up in the air. Some people want to say it is, many people want to say it isn't. We need to regulate it though, no matter what. Whether we call it a pollutant or not a pollutant, we need to regulate how much of it is allowed into the air. So, how do we do that? Well, we put a price tag on it. Put a price on carbon emissions. We can do carbon or energy taxes. Call it a carbon tax or a energy use tax. Once again, I'm in favor of cars should be above a certain mile per hour limit. 45 miles to the gallon, 50 miles to the gallon, whatever is decided. Any car that gets less than that has a tax on it, and it's a tax that you pay every year. But anyway, We could tax pollution while lowering taxes on payrolls and profits. Right now, we largely pay your taxes based on your profit margin. You know, the more money you make, the more you get taxed. Well, instead, we could tax pollution. You put a tax on it. Once again, you buy the bigger car or you buy the car that has less gas mileage, that's what you're taxed on. Not. So the amount of taxes doesn't have to really change. It's not like you're now going to pay this tax as well. We need to shift how our taxes are done, how they are paid. We need to tax the things that are causing the problems. This makes the buyer beware, right? I'm going to make choices about what I buy. I'm not just taxed because I make this much money. I'm taxed on my purchase choices. This would stimulate the economy in actuality, because once again, then people are going to make things that the people want. And if it becomes a priority to cut this down, we're going to come up with ways to do that. Also, we can put a total cap on generated CO2. But let's take a look at this in general. The trade-offs of carbon taxes before we go into the other. Now, once again, carbon tax is pretty simple to administer. You know, you just got to say if you're putting this much carbon with whether it's electricity, car that you buy, anything you buy that would be putting out CO2. We put a clear price on the carbon. It would cover all emitters, and it's fairly predictable revenues. The disadvantages, tax laws can wind up getting really complex, and there's an awful lot of lobbying going on for this, that, or the other. It would be vulnerable to loopholes, easy to sort of jump through this or that. It's not going to guarantee lower emissions. Some people will say, well, I can afford it, and I'm just going to go ahead and buy this, you know, large car that gives a lot of things, or whatever. Once again, it doesn't guarantee it. A lot of us would opt for it, but some people would still choose no matter what. And unfortunately, putting taxes on is politically unpopular because it just sounds like we're taxing more. Of course, the thing to do is not tax more, is to shift how the taxes are collected so that the taxes go directly to what the problem is. The other one, as we talked about, is putting a cap on it. We talk about cap and trade. In other words, you're only supposed to do this much, and if you go over that, then you have to pay, or you get coupons, if you will. And if you have coupons left over, you can sell them or trade them on the market. So an electricity company, they say you're only allowed to produce 100 carbon, whatever it might be. And if they only produce 90 carbon, well, they have 10 carbon coupons left over that they can trade in for money or offset something else. And if you had 100 and you went over your 100, you had 120, you got to buy those from other people that didn't do it. So this kind of caps our overall emission. This person might be a little high, but that means this person's a little low. This is the idea of cap and trade, and it's been used in a lot of areas. Now the trade-offs with this. Now the advantage is a very clear legal limit on, you know, this is what's legal and above that really isn't, and you've got to now go find people that have coupons and they'll sell them to you. It rewards cuts in emission. Anybody who cuts it, they get the coupon. We get a reward. We have money in our pocket, which we can sell to somebody else, trade back on the real market. It shows a record of success. Places that have done this, we have successful areas that have done this up in the northeast of America, some European countries as well, and it's proven successful. And there's actually a very low expense for consumers. It's placed on the companies, not on the consumers. So all the onus is on the company to bring the emissions down. It's worked really well. Disadvantages, the revenues aren't predictable. With tax, it's very predictable what we're going to get out. Here, it's not so much. It's vulnerable to cheating. Trading the coupons around. Sometimes you can kind of trade things around and it looks like something's here when it's not. You can cook the books, if you will. Rich polluters get to keep on polluting. I'm just going to buy mine. I'm going to offset my carbon by buying it. They still keep on polluting. And it puts a variable price on carbon. And this really only works when we set the emissions low enough and you have to keep dropping them. You don't set one standard and keep there. We're going to start here, and over a 10-year period, we're going to drop down to here. So people have to be encouraged to continue to cut them down. Anyway, a couple of ideas, whether it's a tax or a cap and trade, and benefits and advantages either way. One of the things we really need to do is use government subsidies to slow climate change. Currently, most of our subsidies are going to mining and fossil fuel companies. We need to shift the subsidies from fossil fuels to energy efficient technologies. We need to take the money of research and design in fossil fuel and fracking and other things and put it into improving the efficiency and design of solar, wind power, these types of technologies. We've got to phase them out for fossil fuels, phase them into energy efficient, renewable energies. Our government funding for research and development is the same way. We've got to put research and development into our renewables. That's where the future lies. The future is not with fossil fuels. We've got to accept that and put the lion's share of our money into research and development, not really into nuclear, not into fossil fuels, but into our renewables. New batteries, nanotechnology, improving these is really what we need to look at. It's going to take international climate change treaties, like the Kyoto Protocol. The Kyoto Protocol back in 1997 was a treaty. 194 countries showed up. It was not signed by the United States at the time. Now, 2014, the United States and China agreed to put a cap on carbon emissions, but within 15 to 20 years. Yes, we're going to do it, but we kind of set it off long term. China made the agreement, but they didn't really agree to start it until 2030. So it's like, yes, we're going to do it, but when you say you're going to do it and you're going to do it 20 years from now, you got to put your money where your mouth is. It's got to be now. The 2015 Paris meeting, once again, some like 195 countries came together, pledged to meet certain goals. Now, there was really no provision of money to assist poorer countries, which is really what we've got to do. Some of the richer countries have got to be able to assist poorer countries. Once again, when we develop the technology, we need to give it away. We need to develop the technology and then be willing to give that technology to a poorer country so they can leapfrog over all the fossil fuel use. They need to go directly from whatever it is they're doing to solar powers, wind panel, hydroelectric. So we need to help some poorer countries with that. And of course, the president at the time had planned to withdraw from the treaty by about now. So we're relooking at what it is, but we have got to get on board. The most polluting countries, China when it comes to releasing CO2, which I realize is, controversial whether it's a pollutant, but the countries releasing the most CO2, China, the US, and then we're kind of followed by the European Union. It comes into India, Japan. There's about 6 of us that are the biggest. We have got to come on board. We have got to sign on to these treaties, and we've got to do our part in cutting down the emissions. So a part of this international cooperation is just that, technology transfer, hand it away. We've got to do some things to help protect our large forests. The UN's REDD program funds efforts by farmers to help use the forest more sustainably. These are the directions we have got to go to help get climate change under control, or at least slow it down. Now, some countries, some states, and companies are really doing a lot to reduce their carbon footprints. Costa Rica, their goal is to be completely carbon neutral by 2030. They're already at like 93% there. Phenomenal. Most of their power is coming from hydroelectric and then wind and solar. And once again, they expect to be completely neutral by the end of the decade. China and India, they've simply got to change their energy habits. Their use of coal is so high, their use of fossil fuels, that we've got to help them bring it under control. And they've got to do their part there. There's a lot of US cities and states that are taking initiatives to reduce their carbon emissions. California is pretty much leading the charge here, but there's over 650 cities worldwide that have really made a declaration to take their carbon emissions down and have made big, huge steps in doing that. US Climate Action Partnership is part of that a lot of these cities are joining into. Now, colleges and university. A lot of times our colleges and universities pave the way. You know, they're what they're supposed to be, help showing us how it can be done. Some of the best, Arizona State University. They use more solar panels than any other university out there to draw their power from. And they were one of the first to establish a school of sustainability. People from all over come to it. Costa Rica also has a college of sustainability that over 20 nations send their students to learn sustainability habits to carry it back to their countries. UC Irvine, they reduced their electricity consumption by 24% just since 2008. In just a decade, 25% just about reducing. Pretty massive. The Earth University in Costa Rica, the one I mentioned, their sustainable agricultural degree program is outstanding, and people from all over the world come there to study. Then it comes down to you, and it comes down to me. What can we do? Because this is what it's going to come down to. It's got to be you and me making decisions in our homes with our lifestyles to make slowing climate change a reality, to reducing our carbon footprint a reality. 2/3 of Americans' carbon footprint is what we call embedded carbon. It's in the industries out there, right? You know, I shop online, I do this, it's coming from where I get, you know, I turn on my lights, well, it's carbon happening out there, right? I'm not burning coal. So 2/3 of it is embedded. It's energy used in manufacture. So we've got to change some choices. So about 2/3 of the carbon has got to be really government corporation decision. But 1/3 of it comes down to you and me, choices that we make. Diet choices are a big part. Agriculture plays a big role in this. So our diet choices. Processed foods require a lot more energy than fresh fruits and vegetables. Get used to buying, when you go to the grocery store for yourself, hit the outside edge of the grocery store. That's where the good stuff is. Get the fresh vegetables, the fresh fruits, and make forays into the aisles. Don't do most of your shopping with the processed food. Just buy the real food and cook it. When it comes to eating meat, limit beef. Beef requires a lot more energy than chicken, a lot more energy, a lot more water, you name it. Once again, keep away from processed food, stay with natural foods, minimize meat, and especially beef. And there's political involvement, just like Greta Thunberg. In 2019, she addressed the World Economic Forum. In her statement, "My home is on fire. I want you to panic. I want you to do something now." That's the reality. Look around you and realize the house is on fire. This is the time to panic. This is the time for action. This is not the time to say, oh no, everything's okay. We've got to do something. It takes political involvement, and we've all got to get in and do something about it. Reduce your CO2 emissions. Get online, calculate your carbon footprint. Go in, pull up any kind of carbon footprint calculator, see where you're at. Drive a fuel efficient car. When it comes time to get a car and you get the choice to buy one, buy a fuel efficient car. Go with a hybrid or even a full-on electric if at all possible. Bike, walk, carpool, and use mass transit whenever possible. Hop on a bus, take the train. When it's possible, do so. Reduce garbage and reduce consumption. Make sure we're recycling and we're reusing as much as we possibly can. One-use plastics, try and get away from it. Don't use something one time and throw it away. Reuse it over and over and over. Use energy efficient appliances, LED light bulbs by all means. Wash your clothes in cold water. Rarely do you really have to use hot water. If you do anything, use warm. Once again, it's cutting down on the energy consumption. Close the window curtains, block the sunlight coming in, use fans. Lots of things that we can do to help reduce our power load. And the power is our embedded carbon. Use low flow water. Any of these methods of conservation we want to use. Take down your water heater, plant some trees, and work with local businesses. And as you become managers, CEO, people making the decisions, make sure you're making decisions that are good for the climate. Guys, that wraps it up for what we can do. Next time, come back, we'll wrap it up as we talk about adapting to the climate change. Take care, and we'll see you next time.